In this video, I'm going to just give a quick tutorial on how to write electron configurations for elements on the periodic table. I know that I struggled a lot with the subject when I was in high school, so if you're taking chemistry, then this video should help you. Now, the way I'm going to teach this is by pattern recognition, i.e. by just showing you how to do it rather than showing you what you're doing. And in the second part of this video, I'm going to go back and explain some of the science that we're actually referencing whenever we write an electron configuration of a given element on the periodic table. So with that, let's begin. The electron configuration of any element is directly based on the number of electrons that exist in that element. So in order to learn how to write an electron configuration, I'm just going to draw a T-chart, and we're basically going to go from one electron to however many it takes to basically fully explain this concept. So let's just, on the left side of our chart, write number of electrons. Number of electrons. And on the other side of our chart, let's just write, let me pull my camera up here so you can see better. Let's just write electron configuration. Now the way I'm going to do this is I'm going to write the number of electrons in an atom, and I'm going to basically just ask you to, once I write the number, just pause the video, give your answer or your guess as to what the electron configuration is before I actually write it. And then that way you'll basically, through pattern recognition, teach yourself how to do this. So if an atom that exists has one electron, its electron configuration is just going to be 1s1. If an atom or element, if a given element per se, has two electrons, its electron configuration is going to be 1s2. Okay? If a given element has three electrons, its electron configuration is going to be 1s2, 2s1. If a given element has four electrons, its electron configuration will be 1s2, 2s2. If a given element has five electrons, its electron configuration is going to be 1s2, 2s2, 2p1. At this point, hopefully you can start making some guesses. If a given element has 6 electrons, its electron configuration is going to be, what do you think it's going to be? It's going to be 1s2, 2s2, 2p2. If a given element has 7 electrons, what do you think its electron configuration is going to be? It's going to be 1s2, 2s2, 2p3, right? If a given element has 8 electrons, what do you think its electron configuration is going to be? It's just going to be 1s2, 2s2, 2p4. Okay, notice any patterns? Hopefully. If a given element has 9 electrons, its electron configuration will be what? It's going to be 1s2, 2s2, 2p5, right? Okay, just want to point something out. Notice that this number plus this number plus this number equals this number. And in this case, in the 8 electron case, this number plus this number plus this number equals this number. In the 7 case, this number plus this number plus this number equals this number. And in the 6 case, this number plus this number plus this number equals this case. And in any case, the top numbers, this number equals this number plus this number equals this number, and hopefully you see the pattern. So let's keep going. If a given element has 10 electrons, its electron configuration will be what? It's going to be 1s2, 2s2, 2p6. Right? If a given element on the periodic table has 11 electrons, what do you think its electron configuration is going to be? It's going to be 1s2, 2s2, 2p6, 2s1. Oh, not 2s, 3s1. Okay? If a given element on the periodic table has 12 electrons, what do you think its electron configuration is going to be? It's going to be 1s2, 2s2, 2p6, 3s2. Right? If a given element has 13 electrons, what do you think its electron configuration is going to be? It's going to be 1s2, 2s2, 2p6, 3s2, 3p1. Right? Notice, p orbital clusters contain a maximum of 6 electrons, always. S orbital clusters contain a maximum of 2 electrons, always. Any orbital cluster can contain from 0 to its max number of electrons per cluster, always. Okay, so that's just a little bit of the pattern recognition of teaching how you to do this. Let's get into some of the science as to what we're doing when we write an electron configuration of an atom.